Welcome to this session. In this session, we discuss a problem on integration of e raised power ax cos bx dx, where a and b are non-zero constants. Now, this application of integration by parts method. So let's start the process. So I say let u to be cosine of bx and dv to be given by e raised power ax dx. So that's the step one. So we have to get du, and to get du, you will use substitution method. So this part, we differentiate it, we differentiate with respect to x, you get b, and then multiply by the derivative of cos function, which is a negative sine function. So we'll have negative b, and then sine bx dx. And then here, to get v, e raised power ax dx, and then integrating the power, you get a, and then the reciprocal of a times integral of e raised power ax, we get 1 over a e raised power ax. This is just substitution method that can help you to carry out this integration. So integral of u dv is the same as uv minus integral of v du. So integration of e raised power ax cosine of bx dx is uv, and then this our u, this our v. So we have 1 over a e raised power ax, and then cosine of bx minus b du, but because we have a minus sign here, so we'll have plus, and then this a constant, and then this a constant, so it will be b over a integral of e raised power ax. So sine of b x dx. So let's call this integral I. Now we have this part also, integral of e raised power ax sine of bx dx. So what we do, we also use integration by parts. So let u to be sine of bx, and let v be dv be e raised power ax dx. Using chain rule, du will be b cosine of bx dx. Using substitution method, b will be the integral e raised power ax dx, whose value will be 1 over a e raised power ax. We are using substitution method to carry out this integration. Now, the integral of e raised power ax sine of bx dx will be uv, so will be 1 over a e raised power ax sine bx minus b du. So du is given by this and this b, so b minus, I put, so b times 1 over a is b over a integral e raised power ax, and then this is cosine of bx dx. But you see, from where we're coming from, I is the same as integral of e raised power ax cos bx dx. So this is the same as just I. So I can say integral of e raised power ax sine bx dx is 1 over a e raised power ax sine of bx minus b over a times I. because this integral is called I from the starting point here. Now, so therefore I replacing into this, if we call this one equation 1, so, and we call this one equation 2, so replacing 2 in 1, we get I equals, now remember the first term on the right hand side is 1 over a e raised power ax cos bx, and then the sign here is plus b over a, then this second integral. So I have plus b over a. The second integral we have found out to be 1 over a e raised power ax sine of bx minus b over a times I. So the next step, let's open the bracket. So we'll have I equals to 1 over a e raised power ax cosine of bx plus, now opening here, we'll have b over a squared e raised power ax sine of bx minus, so this will be b squared over a squared and then times I. So remember we are solving for I, so collect terms in I. So we'll have I plus b squared over a squared I equals to 1 over a e raised power ax cosine of bx plus b over a squared and then e raised power ax and then sine of bx. So we'll have LCM is a squared, and then, so this is like over 1, so a squared plus b squared, and then we multiply by I. Let's put these ones also under 1 LCM, so we have a squared. A into a squared is a, so a e raised power ax cosine of bx plus b e raised power ax sine of bx, and then we multiply by the reciprocal, so we have I is the same as a squared over a squared plus b squared times a e raised power ax cosine of bx plus b e raised power ax sine bx over a squared. So remember, we need to be adding constants of integration at every point. Let's call C1 plus C1 plus C1. So plus C1. Now you see, I'll have I is equals to, so a squared and a squared cancel out, so we have 1 over a squared plus b squared into a e raised power ax cosine of bx plus b e raised power ax sine of bx, and then plus 1 plus a squared over a squared plus b squared, then times C1. Remember, a, b, and c are just constants. C1, a, b, and C1 are constants. So I can just take this one to be one constant, and I say this is the same as e raised power ax over a squared plus b squared into a cosine of bx plus b sine of bx, and then plus a constant c, where c is the same as this part here. So this is the integral I. So therefore, the integral of e raised power ax times cosine of b x dx is the same as e raised power ax over a squared plus b squared into a cosine of bx plus b sine of bx, and then plus c. So that's how we find the solution to that problem.